So we're looking at page 16, 3 and 4. We're looking at direct variation and sketching graphs for situations. So on each one of these, you need to figure out whether it's direct variation or if it is not direct variation, and then sketch a graph. Okay, so this first one, it says the gallons of water in a tub and the number of minutes since the tap was open. Do those vary directly with one another? Yes. I have people nodding yes. Yes. Why is it direct variation? Logan.
Because the water going into the tub and there's water in the tub, so the variables are the same.
Yeah, so be careful here. As long as the water is going into the tub at a constant rate, it would be direct variation. And we're assuming that. So we can go ahead and sketch a graph. Now on your tests, I'm okay if you sketch a graph and just use quadrant 1 if you like. Okay? So if we use just quadrant 1, which one of these variables, the gallons or the minutes, would be on the x-axis down here? Minutes. So I'm going to put minutes down here. Almost always, your time is on the x-axis. Your time is your independent variable. You can't change time. It goes whether you want it to or not. So that is your independent variable. Your y depends on it. So that's gallons. Your gallons here depend on how long you have the water running for. Okay, where would I start this graph? How full is the tub initially? 0. So I'm going to start at 0 and go up at a constant rate. And that would be just fine with that one. Okay, now we're looking at the relationship between the height of the ball and the number of seconds that it was thrown. Do those vary directly with each other?
No.
No, why not? Macy.
Because the height of the ball, it doesn't, the height of the ball has no association with the number of seconds.
Well, it has some association.
Kind of.
It kind of does, but here's the thing. Does it? Oh, go ahead, Carter.
The height of the ball isn't constant.
Right. It's not constantly increasing or decreasing. So the height of the ball is not constantly, at a constant rate. It's probably going to start at a certain height, maybe go up a little bit, and then fall back down. So it's not linear, which would mean it'd be more likely to be direct. Okay, what would be my x-axis variable here? What would I label that? Seconds. And on the test, I just want a nice rough graph. Like these are nice rough graphs. Okay, just sketches. Okay, and what would be on the y coordinate? Y-axis. Logan, height. Okay. On C, what about, does the length of a side of a square vary directly with the perimeter of the square? Anna says yes. So it is direct. Why is it direct?
Because the length of side of the square, the perimeter will always be 4 times the length.
Yeah, so you're always constantly increasing the side of the square, or the perimeter of the square, based on the side of the square. So if I graph this again, this will be perimeter. And this will be side length. If it were not of a square, then it wouldn't work. Okay? So it does not vary, or does vary directly. Okay? And it's going at a constant rate, which is 4 times. So you can just draw that. Questions there? Last one here. What about the length of the side of a square and the area of the square? Do those vary directly, Wes?
It doesn't vary directly because for the area of a square, it's a unit squared. And if the graph is squared, it'll go up normally at first, but then it'll begin to steepen.
Right, so if I draw this, it's not direct. If I draw this, I still would sketch it with my area on the y-axis and the side length on the x. But you're right, as I start, like, I could do a t-table for this if I wanted to. Side length, area. Side length 0, area 0. Side length 1, 1 squared is 1. Side length 2, 2 squared is 4. Side length 3, area is 9. So this graph is going to look something like that. So it's curving, it's exponential, it's not a direct variation.